Students, now we see in this video see the topic from electrochemistry session 3. The objectives of the electrochemistry session 3 is variation of molar conductivity concentration, Debye-Huckel and Onsager equation and Cholera's law. Okay, now we follow that. One by one I will explain. Now variation of molar conductivity with concentration. What are the effect or what are the impact of the concentration in solution with molar conductivity? One by one I will. First point, the Cholera's study the molar conductance of different electrolytes at different concentration. See the tablet column, the concentration is 0.1, 0.01 and 0.001. This means more dilution up to bottom, decreasing the concentration. Okay, molar conductance in terms of lambda m, that is sodium chloride, potassium chloride and hydrochloric acid, they increase gradually increasing because more dilution, more conductance is there in already see the topic. Okay, now what are the effect? He observed the increase of molar conductance on electrolytic solution with the increase in dilution, increasing in dilution. This is the important point in this lesson also. More dilution, more conductance is there. Okay. Now the results are given in the tablet column. Okay. Next point, based on the above such results, Cholera's deduced the following empirical relationship. This is the formula for the Cholera's law. Lambda m is equal to lambda m0 minus k root c, where c is the concentration. You already know that k is the constant value, lambda 0m, this is a new concept in this equation. This is the limiting molar conductance, lambda m is equal to molar conductance. So in this relationship we find the electrolyte, the molar conductance of the electrolyte. Okay. Next, from the above equation, that is lambda m is equal to lambda 0m minus k into root c. From the equation you plot the values in the this graph. One x-axis the concentration root c value, and then y-axis lambda m value. He filled the values as per the x-axis and y-axis values. Okay, he plot the curve for weak electrolyte and strong electrolyte. He get the slope from this graph. Weak electrolyte concentration decreases with the increase of root c value. This is the conclusion from this graph. Decreasing y-axis top to bottom, decreasing the value of concentration. Again it reaches to 0 at one point. So the concentration decreasing with the increasing root c value from this graph for weak electrolyte, because of more dilution. This is the graph. Lambda m value is decreasing with the increasing concentration. Okay. Next, strong electrolyte, only the straight line is appear. Straight line, he get the straight line. So this is the difference from this graph. Okay. Now the above equation represent a straight line in the form of y is equal to mx plus c. You already know that mx plus c, this is the algebraic equation. Hence the plot delta m versus root c value. Delta m is the molar conductance and root c value is the concentration. The straight line with the negative slope minus k and y intercept lambda 0 m. From this slope, from this graph get the lambda 0 m value. Lambda 0 m value is the molar limiting molar conductance. Limiting molar conductance. He get the limiting molar of the conductivity. That is the molar conductance approaches a limiting value in very dilute solution. Very dilute solution. This is the limiting molar conductivity. Underline it. This is an important point. From the strong electrolytes such as potassium chloride and sodium chloride, the plot delta m versus c gives the straight line as shown in the graph. Straight line. This is the straight line. Okay. Gradually decreasing with the straight line. Okay. For strong electrolyte, potassium chloride and sodium chloride. But weak electrolytes gradually decreasing with concentration increasing. Concentration increasing. Okay. The lambda m value is decreasing with increasing concentration. Okay. For strong electrolyte, from the above graph, the strong electrolyte at high concentration, strong electrolyte it gave a straight line. The number of constituent ions of the electrolyte in a given volume is high. The number of constituent ions means positive ion or negative ion concentration is higher than the dilute solution. Understand? The given volume is high and hence the attractive force between the oppositively charged also high. Attractive force means positive ions surrounding negative ions are there, negative ions surrounding positive ions are there. The attractive force between these ions, positive and negative, anion and cation, between them are strong in strong solution. So the conductance is less. Okay. This is the very important conclusion. Next, the ions also experience a viscous drag due to greater solvation. This is another one, viscous drag due to greater solvation. More concentration here, the term more concentration. Next, these factors attribute low molar conductivity at high concentration. This is the important point for already explained that high concentration means the ions are more close to each other. Positive ions surrounding negative ions, negative ions surrounding positive ions. The cloud is there. So the conductivity is less. When the dilution increases means curve concentration lambda m value is gradually decreases with increasing concentration. From the graph, the curve is attractive forces decreases. Due to the attractive forces decreases because you add the water with the solution, sodium chloride or potassium chloride, the sodium plus ion and Cl minus ion, or potassium plus ion or Cl minus ion distance is away from the from each other. So attractive force is less, conductivity, more conductance is there, more conductivity is there. In finite dilution, the ions are so far apart. Apart means so distance away from the distance. Attractive force is so less. So the interaction between them becomes insignificant, and hence the molar conductivity increases and reaches maximum value at finite dilution. The conductivity is maximum value. From the graph, already know that it reaches the zero concentration. Zero concentration, more conductivity is there. More conductivity, more conductance is there. So these are the impact of the dilution and strong electrolytes. For weak electrolyte, high concentration, weak electrolyte, high concentration, the almost parallel to the concentration axis. Parallel to concentration axis means this is the axis. Weak electrolyte, any weak electrolyte, high concentration is there, means the lambda m value and root C value with this, the straight line will appear. This is the strong electrolyte. Strong weak electrolyte, high concentration. The conductivity as dilution increases. Already say the topic, say the conclusion from the graph, Cholera's graph. Okay. Next, when the concentration approaches to zero, this is the concentration, this approaches to zero, the sudden increase the molar conductance. Concentration value is sudden increase the molar conductance. The curve is almost parallel to the axis. This is the concentration is zero. Zero means sudden increasing delta m value. So this is the graph. From this graph we see the this point. This is due to what is the reason for this? The dissociation of weak electrolyte increases, more dilution. Ostwald dilution law. As per Ostwald dilution law, it takes the more dilution, more dissociation of the weak electrolyte, more dissociation. Okay, positive and negative ions are more dissociation takes place in high dilution. Lambda 0 m value. Lambda m0 value of strong electrolyte can be obtained by the exploiting the straight line from the graph. Straight line. This is the straight line from this. Same procedure is not applicable in weak electrolyte. Weak electrolyte is not suitable for this conclusion, because the plot is not linear one. In weak electrolyte, no linear type. It is a curve. Curve means decreasing conductance with increasing concentration, up to down. This is determined by Cholera's. Delta 0 m values of the weak electrolytes can be determined using this Cholera's relationship. Already see the formula. Delta m is equal to, lambda m is equal to lambda 0 m minus k root c. That is the Cholera's law. Next, Debye-Huckel-Onsager equation. This is very, very important 5-mark question in this lesson. For public exam also very, very important. Debye-Huckel and Onsager equation. The influence of ion-ion interaction on the conductivity of strong electrolytes was studied by Debye-Huckel. Debye-Huckel, what he told, he determined the ion-ion interaction between the conductivity of strong influence of ion-ion interaction. Influence of ion-ion interaction means positive ions surrounding negative ions are there, negative ions surrounding positive ions are there. This is the conclusion. Okay. Considered each ion surrounded by the ionic atmosphere of opposite sign. I already told that one positive ion surrounding with so many negative ions, and one negative ion surrounded with so many positive ions due to the attraction of the oppositive charge. So the molar conductance of the strong electrolyte with concentration, assuming the complete dissociation. This term is introduced, the Debye-Huckel. Complete dissociation, where when the complete dissociation is there, more dilution, complete dissociation. Strong electrolyte, no small part of complete dissociation is there. This is the equation. This is the conclusion. Next point, Uni Univalent Electrolyte. Uni Univalent Electrolyte, I give the meaning for the Uni Univalent. Valence or charge is 1. Valence or charge, any one, which molecule have the both positive and negative ion charge is 1 or valence is 1. So that is univalent electrolyte. The de Broglie-Unsager equation for univalent, lambda m is equal to lambda 0 m minus a plus b lambda 0 m bracket a plus b lambda 0 m root c. This is the relationship between the de Broglie-Unsager equation. Lambda m is equal to lambda 0 m minus a plus b lambda 0 m bracket into c. This is the relationship. This is for univalent valence of electrolyte, univalence. Next, the new term A and B is introduced by de Broglie. This is the separate formula for A and B. This is a big derivation in is there. So you will learn in higher studies. Okay. Not now. You will not. You need not worry about that. A is equal to the derivation formula is noted 82.4 divided by root of dt eta. This is the eta, name of the symbol eta. Eta is the viscosity in terms of viscosity. 82.4 divided by root dt eta. This is A, and B is the 8.20 into 10 to the power of 5 divided by root cube of dt, where D is the dielectric constant of the medium. Dielectric constant of the medium. Dielectric constant of the medium. Temperature T. Eta is the viscosity. This is the term. Okay. You follow this two value. You substitute in this relationship. This is the de Broglie and Unsager equation. A and B is the constants, where the formula 82.4 divided by root T eta and 88.20 into 10 to the power of 5 root cube dt. Okay, this is the detail for D and T and eta. Eta is the viscosity. Okay, next Cholera's law, very important, another 3 mark question or 5 mark question. Cholera's law. The limiting molar conductivity is the basis for Cholera's law. Cholera's law, this is the law. Second point is law. At infinite dilution. Infinite dilution means more water, add more water. This is the relationship. More add water. The limiting molar conductivity of the electrolyte is equal to the sum of the limiting molar conductivities of the constituent ions. Constituent ion means positive ion and negative ion. The addition of molar conductance of these ions, separate molar conductance. These are the law of Cholera's law. That is molar conductivity due to the independent migration of cations in one direction and anions in opposite direction. You already know that cations are moved to electrodes. Cations is positive charge, positive electrode move towards positive electrode, and anions are moves to negative electrode. So these are the concept. The molar conductivity is due to the independent migration of the cations from one direction and opposite, anions to the opposite. So the relationship is lambda 0 m NaCl, that is limiting molar conductivity of NaCl is equal to lambda 0, small lambda 0 m Na plus ion. This is the constituents, separate constituents, Na plus Cl minus, lambda 0 m Cl minus. This is the relationship for Cholera's law. Very important law. Next, According to the Cholera's law, the molar conductivity of infinite dilution of the electrolyte AXBY. AXB is the example for molecule, any compound AXBY. Okay, you example NaCl, KCl, or HCl, or HNO3, or any one. You take the electrolyte, example for electrolyte AXBY. A is the cation, B is the anion. That is, X and Y are the number of atoms. That is, the Cholera's law for molar conductivity of infinite dilution. This is the important point. Infinite dilution. Infinite dilution take more dilution. The lambda 0 m AXBY is equal to X into, X means number of atoms, number of atoms X. X is before that lambda 0 m A Y. Y is the B, number of B atoms Y. A Y plus Y into, Y is the B, number of B atoms Y into lambda 0 m Bx. X is the number of atoms in X. So XY relationship in this equation, this is for the molar conductivity of the AXBY infinite dilution. Cholera's arrived the above relationship, the following tablet column, very important, the electrolyte KCl, NaCl, lambda 0 m. He find out the difference is gradually same difference value. KCl, NaCl, KBr, NaBr. Only the positive ions are changes. Here KCl, NaCl, only the positive ions are different. Negative ions same. KBr, NaBr. KNO3, Na1O3. This is the same, difference is same value, already same differences. KBr, KCl, same positive, different negative ions. Here the value difference is some same value for difference. Okay, KBr, KCl, NaBr, NaCl, LiBr, LiCl. Understand? This is the tablet column. The relationship between these values are getting from this relationship. Okay. From the above relationship for the formula, the result, so the infinite dilution, each constituent of ion electrolyte makes the definite contribution towards the molar conductance of the electrolyte, irrespective of nature of the other ion with which it is associated. Nature of ion with it associated. Example for this relationship, lambda 0 m KCl minus lambda 0 m NaCl is equal to the difference value. Here lambda 0 m K plus and lambda 0 m Cl minus separate you split into the above formula, Cholera's formula. Lambda 0 n plus and lambda is equal to this value, this difference value. Okay. Now cancel the common. This Cl plus and this Cl minus is cancelled. So lambda 0 m K plus minus lambda 0 Na plus equal to this value. So the conductance lambda 0 m Br minus and Cl minus is another for same cation, same anion and different cation, that is Br minus and Cl minus, like this 2.06. This is the relationship, the value table from this type of relation. The values are getting the different chemicals. Okay, understand? Okay, in this session finish. Okay, thank you.